Okay, ji. So today we are starting off with Lamis theorem. This is forces and equilibrium lecture number 8. To apply this theorem, what you need to understand is to apply this, there are conditions that must be satisfied. Conditions must be satisfied. Number one, there must be three forces only. There must be three forces only. Number two, the resultant of three forces must be 0 or the object must be in equilibrium. Equilibrium. Right? So these are the two conditions. The third condition is that the direction of all forces must be same, either inwards, either it should be inwards or outwards. So these are the three conditions that must be met before the Lamis theorem to be applied. Now, Lamis theorem is normally considered as sine, just like sine rule. Let's say we have sine A upon A is equal to sine B upon B sine C upon C. So for Lamis theorem, you need to understand that it's just like your sine rule. So let's just work on the current example. Let's say there's a point, and the point has, this is becomes force 1, this becomes your force 2, let's say this becomes your force 3. Then, so what do we have? Let's just mark this as force 2 and force 3. So this angle will be the angle of force 2. This angle will be the angle of force 3. This angle will be the angle of force 1. So when we are applying this, we need to understand that the angle for force 1, this will be the angle. For force 2, this will be the angle. For force 3, this will be your angle. Now, at this point, you need to understand that all the directions are moving outwards. Either this will be the case, or the case should be in this way, that there's a point, let's say there's a force, there's another force, and let's say this is your third force. So your third force, three forces. So now the forces are inbound. This is force 1, force 2, force 3. So this should be theta 3, this should be theta 1, and this should be theta 2. So what are you trying to understand? That means at this point, all the forces are going inwards. In the above example, all the forces were outwards. So here's an example question of the same Lamis theory to be applied. Now, we need to find out what? We need to find out W1 and we need to find out W2. These are the force. For W1, we have been given 120, whereas another force, another angle is already given. So when another force, another angle is already given, so what we can do is we can solve using the Lamis theorem, which will be W1 upon sine 120 is equal to, we can always have W2, that is 5 upon sine 100. So W1 will be 5 sine 120 upon sine 100. So the answer for W1 will be 4.39 Newton. Whereas same case can be applied for W2 as well. For W2, what we can do is, for W2, we can apply W2 upon sine 140, W2 upon sine 140 is equal to 5 upon sine 100, because this is already given. So W2 will be 5 sine 140 upon sine 100. So W2 should be 3.26 Newton. So these will be the forces that will be applied for W1 and W2. Moving to another example. Okay, so here's another example question that we have, in which we need to find the theta and the force that is represented by W newtons, right? So first things first, we know that the force is given and the angle needs to be found out, but another force, another angle is given. So the answer for this can be represented using, let's say, sine theta upon 5.5 is equal to sine 90 upon 7.3. So if we need to find out theta, this should be sine inverse. It should be 5.5 sine 90 upon 7.3. So theta value that we will have is 48 point. No, theta value that we will have is 131.1, right? Why is that so? Because this is an obtuse angle. So this will be represented by 131.1. But on the other hand, if you just note that we need to find the angle, right? So if you just have the straight line ahead, so the acute angle that came through the same formula would have been 48.9. Now, once we subtracted by 180, so we got 31.1. Yeah. Now, considering that since it is an obtuse angle, so we made sure that we get what, 131.1. The answer that we will be getting is what, 48.1. But we know that it is an obtuse angle, right? More than 90 degree. So this should be 180 and this should be 48.1. Now, knowing the fact that this is 90 degree, this is 131.1. So we can find out the angle that is for the W Newton, which will be 138.9. 138.9 will be the angle. You can either add 90 plus 131 and subtract it by 360, or you can also find this angle, which will be 41.1, and then subtract by 180 to find 138.9. Now, since we need to find out the angle that is corresponding with the W Newton, so that particular phase, this should be with the working, since W Newton has to be find out, the angle representing this is 138.9, which is equal to, we already know that we had 7.3 upon sine 90. So for W, we have 7.3 sine 138.9 upon sine 90. So in this way, we will find out what the W Newton as well. This will be 4.80 Newton. So this will be 4.8 Newton. So these are the two values that we found out. One value was the theta, which was 131.1, knowing the fact that we normally have the acute angle and then subtracted by 180 to find 131.1. We can add 90 and 131.1 and subtract it by 360 to have 138.9. And obviously this should be the opposite to this angle. So knowing the fact 7.3, 90, and W will be against 138.9. So we tend to find what? 4.8. So this was your Lamis theorem for forces and equilibrium.